Hello students, welcome to Physics Pathshala. Today we'll cover Physics Class 11 Part 1 Chapter 1 Physical World. As the name indicates, the world which is visible to us, whether it is visible to naked eye or with the help of instruments, that means it's having physical existence, is the physical world. And study of this physical world or study of nature and natural phenomena in a scientific method is termed as physics. That means physics is a branch of science and it is a study of nature. Nature is the physical world we see around us. Study of nature and all natural phenomena, that's all the activities happening in nature, will be covered under physics. Now, under this physical world, we'll be covering what is physics, categories of physics, and different types of fundamental forces and law of conservation of energy. As you understood, physics is study of nature and natural phenomena, and it is a branch of science. Science is study on any subject to gain knowledge in depth using scientific method. Scientific method is observation, experiment, and mathematical equation. This observation is continual observation. Experiment is controlled experiment, or that will get mathematical equation. With this, we will be able to predict the future happenings. This is scientific method. Any subject is studied under the scientific method is termed as science, and branch of science in which we will study nature and natural phenomena will be termed as physics. Now, depending upon the size of the matter, we have categorized physics into two categories. One is classical physics and another is quantum physics. Classical physics is the study of macroscopic particles or objects, whereas quantum physics is study of microscopic objects or particles. In this, it includes atom, molecule, and nuclear phenomena. This macroscopic will be again further categorized into, or this classical physics is categorized into mechanics, electrodynamics, thermodynamics, and optics. In mechanics, we'll be studying objects having particles having its mass and its motion. That means under mechanics we'll be studying motion of particles, whereas under thermodynamics we'll be studying heat flow, and under optics we'll be studying deals with light. Electrodynamics deals with electric charges. It may be static or dynamic. If it's static, we'll have electric field. If it is dynamic or moving, electric charge moving, we'll have magnetic field. And both are interrelated. Combined, we will be studying as electrodynamics. Now, under fundamental forces, we'll have major four forces: gravitational force, electromagnetic force, and strong nuclear force. And another fourth one is weak nuclear force. This gravitational force linked with force between objects having masses, and it is always attractive. Electromagnetic force deals with charges. When charges are at rest, electric field is generated due to one charge, and this will have force on another static charge. When charge is in motion, it, one magnetic field will be created, and this magnetic field will exert force on another moving charge. Hence, it is related. And electric this force due to static electric charge is either attractive or due to this charge side may be repulsive. If two like charges are there, it will be repulsive, and like charges, it will be attractive. Now, strong nuclear force is the force between proton, 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 neutron, and neutron, neutron. That means inside the nucleus, proton and neutron are get binded due to the strong nuclear force, irrespective the in spite of the repulsive force between proton, proton, and neutron, and neutron. This is the strongest force greater than this electromagnetic force, and electromagnetic force is greater than gravitational force. Weakland force is linked the force generated during beta decay. Now, the last one is law of conservation energy deals with conserved quantity. When the conserved quantity is force, then the energy associated with it remains constant throughout the activity. The law of conservation says total energy remain constant. Energy cannot be created nor be destroyed. It only can convert from one form to another form and will remain constant. Conserved quantity is if any quantity remain constant throughout, irrespective with respect to type. In this case, if constant quantity is force, then like force under gravity, when object is at certain height, falls freely to ground. At height, it has potential energy and kinetic energy is zero. And in the mid, in between the path, it will have potential energy plus kinetic energy, and at ground it will be purely kinetic energy, whereas potential will be zero, and everywhere once we combine, the total energy remain constant. This is the brief idea on physical worlds.